In this particular problem, one more time, I see a trig, another trig, so I need to build a triangle, trig, trig, triangle. The inside here is an inverse trig function, and every inverse trig function is an angle measure. For these ones, we're gonna build our triangle in quadrant 1 when we have that variable u. I take and just say specifically that what's inside parentheses is an angle measure, so I'm calling that theta. If I take the cosine of both sides, then I'm gonna have the cosine of theta and cosine of cosine inverse. It's gone, so just u. Next, I'm gonna build that triangle in quadrant 1. And to build the triangle, I wanna emphasize for cosine, SOHCAHTOA, that it's adjacent over hypotenuse. I'm gonna put this u over 1 just to emphasize that this is the adjacent and that's my hypotenuse. Okay, we're gonna build that again in quadrant 1. Anytime you have these u values, you're gonna build that in quadrant 1 generically. And now I'm gonna label my sides, so adjacent, so this side is u and the hypotenuse is 1. We want to use the Pythagorean theorem to find this missing side. So u squared plus unknown squared equals 1 squared. And if you solve for the missing side, you're going to get the square root of 1 minus u squared. Let's go back and just replace cosine inverse of u with theta and take a look at that again. So that's now sine of theta. Looking at our triangle, we can find the answer to sine of theta because the sine, SOHCAHTOA, is opposite over hypotenuse. So it's going to be square root of 1 minus u squared over 1. And over 1 simplifies just to the numerator.